So we're going to start here at numbers 2 and 3. And the question was to use a unit circle to define the cosine of theta and sine theta. And then we're looking any theta in the unit circle between 0 and 360. Okay, so with this idea, first of all, what's the unit circle? We have a unit circle. What do I know about the unit circle? Yeah, the radius is 1. So I'm just going to put a point anywhere. I'll put it in quadrant 1. And I'll call that point xy. I'll make a radius of 1. All right. So if I have that, I want to draw the reference triangle first. And the reference triangle always goes to where? X-axis. The x-axis. So if I draw that, then what are the dimensions of that reference triangle now? What's this length right here? X. And what's the vertical length here? Y.
Is today Thursday?
So once you have that reference triangle, now we want to look at the definition of sine and cosine. So if I do sine, now remember theta, since we start right here on the positive x, we always start here. And theta is the angle going to that line segment. So we're going to call this theta right here. So what would be sine of theta in terms of that picture? Kendra, what's sine? Right, so sine is opposite over hypotenuse, right? And our opposite side from theta is y. And our hypotenuse is that 1. So we could just put that it is y over 1. And I'm putting a 1. I know you don't need the 1 right now. I'm putting it for what I'm going to talk about here in a second. So sine theta will be y over 1. Okay, what about cosine theta? The cosine is the adjacent side over the hypotenuse, so that would be x over 1. And then it says, then explain how to use cosine and sine to define tangent. I might do this backwards. If I were doing tangent here of theta, what would I do? What would tangent of theta be in terms of x and y's? Y over x. So tangent of theta is y over x. So, but it says I want to use it in terms of sine, cosine, and sine. Well, what was sine theta again? Y, right? Y over 1 or y. And what's cosine theta? X. So what would tangent theta be in terms of sine and cosine? Yep, sine over cosine. So all we did there is we said since sine theta equals y and cosine theta equals x and tangent theta is y over x, that means we could say that tangent theta is sine over cosine. Make sense? Just substitution there. Okay, now we can extend this a little further, and that's why I put it over 1, is if I change this to an r for the radius. So now it's not necessarily a unit circle. It could be any circle. I change it to the radius. How is that going to change sine and cosine? It'd be y over r and x over r. Is that going to change tangent at all? It'd be r sine theta over r cosine. But the r's are canceled. It's still sine over cosine, right?
So it's always sine over.
It's always sine over cosine, regardless of a unit circle or not. So those always work, okay? And the whole goal here is, maybe you remember this, and this should kind of make sense. We were just working last week or a couple days ago with using that point right there, right? Remember, and this point right here was always cosine theta, and this point right here is always sine theta. Well, now you can see y also in this term because cosine is always x and sine is always y. Okay, so that's number 2. Now it says show your method in the previous question allows you to find those for numbers greater than 360 or less than 0. So, well, here's the thing. So these are defined from 0 to 360. That will work. What if I had an angle of 540? Would it still work? It's bigger than 360. So I think about it as we start right here. We go counterclockwise, 360. Another 180 would be 540. So really, we're just still using the same angles. It's just we can go around the circle as many times as we want. So if we wanted, I don't know, sine of 1,000 without a calculator, and you're like, oh, 1,000's a lot. Well, I start here, go around once is 360, go around twice is 720. I want 1,000, so that's another 280. So here is 270, 280. So if I can find the sine of 280, I can find the sine of 1,000. They're the same thing. And then if you think about 280, I know that that is only another 80 degrees to this reference triangle. So I could use that also. So the whole goal here is to understand that we used to only deal with trig functions for right triangles, and those numbers were always between 0 and 90, right? Well, they still kind of are. We just go back to those whenever we look at these trig functions. So we're looking at functions that are bigger than 90. We can use a unit circle to get up to 360, and even those we can break down into a reference triangle like this, where our angle is going to be less than 90. We're back to what we were working on before. And last question, it says, what do you suppose it means for an angle to be negative? What do you think? If I want a negative angle, what do you think I do? What's that?
You go on the opposite side of the x-axis.
Yeah, so you start this way?
Yeah.
So this counterclockwise is a positive angle, so clockwise is a negative angle. So this angle right here, if I started right here, where I usually always start, and go, that would be negative 90. But negative 90 is equal to what? To this right here, to 270. So negative 90 and 270 are equal. If I go negative 330, so negative 330, what does that equal to? Positive 30.
Why is it equal to?
Because
If you're going around 330, you're at the same spot you'd be if you went positive 30.
so even though, I'll give a second to absorb that.
360 minus it.
So even though we're going negatives and positives, all that really matters is where this point ends up. If you keep on going around in any direction, all that matters is where do we end up, and what does that equal to in terms of where we could have started in our usual direction?
You just take that number and subtract it from 360.
If you're going in that direction, yes.
Okay.
Okay?